Rotational velocity, they talk about in the video, it's how much an object rotates relative to a point. So if you look at something spinning, you have to choose a point of reference so that you know how often it spins. For example, I look at a tabletop and I look at how the bottle spins relative to the table and I count how many times it spins. So you flip the bottle and see how fast it's spinning. When you watch the video, notice how the tennis ball spreads out and slows down the spin, allowing it to land. The reason they switch to a tennis ball and they say, oh, let's reduce 10 to the 24 to 2, they're referring to the amount of molecules of water in the bottle. And by using two tennis balls, it's a very simple way of seeing the interactions, what's happening inside the bottle. Notice the shape of the bottle also contributes to being able to land properly. Inertia, we talk about in the video also, is the resistance of an object to its change in velocity. What does that mean? The object will keep moving forward at a constant speed. Mr. Gary slips on some slopy floor, and my inertia carries me forward. It's hard for me to stop, unless you have an equal and opposite force acting on me. So that's inertia in a very simplistic way. So in the water bottle lab, what matters? The size of the bottle matters. The amount of water matters, and how fast it spins is rotational velocity. You should have experimented with different size bottles. Because you had a group, you should have been able to talk about, oh, does the size of the bottle matter? Maybe, maybe not. I find that large bottles are hard to flip because they tend to speed up too much or they're unbalanced. The water knocks it over. I find medium bottles tend to work very well. Your normal water bottle, 250 milliliters or so. If it's too small, it'll flip too easily. It picks up too much speed. The water carries it over and falls over. It's hard to land it. Small bottles also have smaller bases, so it's hard to land the small bottle. Square bottles work really well because the bottom of the bottle really makes a difference. If it's circular and very small or uneven, it's hard to land it. If it's square, it tends to land very well. The amount of water in your experiment should have shown that too much water, you get too much spin and it won't slow down. You might not have been able to quantify it like that. You might say, oh, there's too much water, it just falls over. You might not be able to tell me why, but too much water and it doesn't slow down the rotation, the bottle won't land. Too little water and you can't decrease the rotational velocity, same problem. The water shifts to the top of the bottle as you spin it and speeds it up too much and it won't land. Halfway allows for a decrease in rotational velocity, which is why the bottle will stop. The rotational velocity, so the size of bottle and the amount of water, contribute to the speed, spinning speed. You need the spin to be one spin, 180 degrees. Two spins, and it tends to be too fast, it won't land. The momentum, which is the mass times velocity, will carry the bottle and follow it over. So inertia and momentum are very much similar. However, momentum is a vector quantity. It has a direction and magnitude. As you study science, certain things have a direction and a magnitude. They use arrows to show a vector. You learn about this in math later on this year. For now, momentum is your mass times the velocity, how fast you're going, in what direction you're going. Inertia is just a simple, you just keep moving. There's no direction. It's just you can actually find a value for it.